Hi, thanks for joining me today. I've got a quick number theory problem for you. We have integers a, b, and c such that a to the 4 plus 2b to the 4 equals 5c to the 4. We want to find these integers. If you want to have a go at this problem, pause the video now and give it a go for yourself, but I'm going to dive right in. So first thing I noticed with this problem is that it's got something to do with integers raised to the power of 4, because all of these guys here are to the power of 4. Also, we've got, well, lots and lots of integers here, and from doing lots of number theory problems before, I noticed that we can apply a little trick here. I noticed that if I did have a solution to this equation, so let's imagine there was a solution where, ABC was, let's make up some numbers here, 8, 4, and 3. That might be a solution, I'm not saying whether it is or not, but imagine it is a solution. Then what I can do with each of these numbers is multiply them by any number I want, let's say 7. So I get 56, 28, 21, and then this would also be a solution because essentially all I've done is I've multiplied both sides of my equation by 7 to the 4. So essentially I only need to find kind of the base solution for each family of solutions, and so if I found 843 was a solution, then I can just multiply that by any integer I want and generate more and more solutions. So with that being said, we can assume that without loss of generality, the greatest common divisor of A, B, and C is 1. So they don't share any factors, because if they shared a factor like here, they all share a factor of 7, I can just strip out that factor of 7. Cool. Okay, so we're assuming that A, B, and C have no common factors. And now what we're going to do is use the fact that this has got something to do with integers to the power of 4. So let's just take an arbitrary integer x. And here's what we're going to do. We're going to notice that x, we know, can be written in this form here. 5k plus r, where r is just a number between -2 to 2. So what am I saying here? I'm basically saying that x is at most 2 away from a multiple of 5. And this is obviously true for any integer. You take, let's go 402, that's 2 away from 400. If you took 39, that's 1 away from 40. So every number is at most 2 away from a multiple of 5. Pause! I've decided to set up my own tutoring company to help you study maths at a top university. So if you like the way I explain things, go check it out. Let's get on with the video. Now let's raise both sides to the power of 4 here. Excuse me. So x to the 4 is going to be 5k plus r to the 4. And we're just going to use the binomial expansion here. So this is 5k to the 4 plus 4 choose 1 times 5k cubed times r, and so on all the way down to 4 choose 3 times 5k times r cubed plus r to the 4, like so. And now the great thing about this is clearly a multiple of 5. This here is also clearly a multiple of 5 because it's got a 5 cubed in it. In fact, all of these terms up to here will all be multiples of 5 because they've all got a 5k in them. So essentially what we're doing is, if you've seen modular arithmetic before, is we're looking at this mod 5. And so we're going to focus on r to the 4. And if you just test each of these numbers here, r to the 4 is either going to be 0, and that's if r is 0. It's going to be 1 if r is -1 or 1, or it's going to be 16 if r is 2 or -2. And so therefore, because 0, 1, and 16, they are either 0 or 1 more than a multiple of 5, I can say that this is either 0 or 1 mod 5. Okay, so essentially all I've done here is I've proved that if you take any integer, raise it to the power of 4, it's going to give you either a multiple of 5 or 1 more than a multiple of 5. Okay, let's revisit this thing here. Now, it's pretty clear here that this right-hand side is a multiple of 5. It's 5 times c to the 4, so it's 5 times an integer. So that means that this side here has to be a multiple of 5. Okay, well, a to the 4, if we use this result here, a to the 4 we know is either 0 or 1. And what about 2 times b to the 4? Well, b to the 4 is either 0 or 1, mod 5. And so if I double it, that's either 0 or 2. Okay, so I'm doing a number which is either 0 or 1, plus a number which is either 0 or 2, mod 5. And so there's a few possibilities here. I could either get 0, 1, 2, or 3. But this side here is always going to be 0, mod 5, sorry. And so therefore, the only way that the left side can equal the right side is if these numbers here are both 0, mod 4. So therefore, a to the 4 equals 0 mod 4, and that's also the same as b to the 4 mod 5 this is. And so if a to the 4 and b to the 4 are 0 mod 5, that means that a and b are 0 mod 5 as well. So they're multiples of 5. But the issue with this is if a and b are multiples of 5, if we just sub them into this, so let's say a is 5m, b is 5n, and sub them in here, we're going to get 5 to the 4 times m to the 4 plus 2 times 5 to the 4 times n to the 4 equals, and then 5c to the 4. And if I just divide everything by 5, I get that c to the 4 is, well, 5 cubed times something, because these 5 to the 4s will turn into 5 cubes. But in particular, c to the 4 is a multiple of 5. And that means that c is also a multiple of 5. So c is congruent to 0 mod 5. But this contradicts this fact here, that a, b, and c are 1, or they have a greatest common divisor of 1. So that means that there are no solutions if a, b, and c are to have any common factor that's at least 1. And so the only way that this is possible is if a, b, and c are 0. So that's obviously a solution here, and we've proved that there can't be any others, because if there was, we could try and take the base solution of that, but then even then they'd all have to be multiples of 5, which is a contradiction. So this is an argument either by contradiction, or you could use infinite descent to finish this one off. Anyway, I hope that solution has made sense, and hopefully you've enjoyed this video. Thanks so much for watching. Do give it a like and subscribe if you haven't already. I'll catch you in the next one. Have a great day.